All right, first thing we got to make sure we understand is that when you're talking about the histology of bone, you're talking about the cells, bone cells. You're looking at bone cells, and a very important bone cell is your osteoblast. You see? And he's similar to what we call fibroblasts. You just came from chapter 4?
Yeah,
so fibroblasts make connective tissue.
Right.
And bone is a type of connective tissue. So when you talk about osteoblast, you're talking about just a different type of fibroblasts. Okay? Osteoblasts are slightly different though. Why? Because what fibroblasts created, what they created was extracellular matrix.
Yeah.
But he does the same thing. I told you they're similar.
Right.
And don't forget, ECM, extracellular matrix, is made of what? Protein fibers, right?
Okay.
Protein fibers and what?
Mm-hmm.
Ground substance. Okay? Yes, protein fibers were your collagen, your reticular fiber, elastic fibers, right? And then your ground substance was your glycosaminoglycans, your proteoglycans, right? Those are the glue that stuck your cells of your connective tissue and the protein fibers together. Ground substance is like this sticky material, right?
Oh,
that's what ECM is. Extracellular matrix for connective tissue, protein fibers, and what?
Ground substance.
Right? In fact, osteoblasts, they do the same thing. They make the what? Protein fibers, which are called what? Collagen.
Right.
And your what? Reticular fibers and elastic. More collagen than anything, though, right? Yeah. Because this is a harder type of connective tissue. Much harder, right? Yeah. So it's a lot more collagen, right? All right. And that's what osteoid is.
Okay.
Yeah. See, for bone, when we talk about bone tissue, osteoid is the what? ECM. But that's not how bone is. See, what these osteoblasts do and what makes them different than fibroblasts is that they actually not just create this material, which is extracellular matrix. They add to it what? They add who to it? Calcium. You see that?
Yeah.
And see, that's a mineral. You see that? And it's a lot of other minerals, not just calcium, it's phosphate as well, right? PO4, right? Manganese, yeah? Magnesium, you know what I mean? So it's a lot of other, etc., right? See, these are minerals.
Right.
Is that okay?
Yeah.
What do they call? Minerals. That's mineralization. So so that's what's special. Bones is a different type of connective tissue then, because not only do you just have your ECM, ECM, that's what we learned about chapter 4. But what are these osteoblasts depositing? Calcium.
Mineral.
You see that?
Yeah.
Okay. In fact, that's what distinguishes bone tissue from cartilage. Cartilage and bone tissue have the same amount of collagen.
Right.
I'm going to say that again. Bone tissue and cartilage have the same amount of this. That makes it really, really hard, right?
Okay.
Yeah, no. Cartilage is like what consistency? Like plastic.
Yeah.
But bone is like what? Brick.
Like
it's
brick.
a little bit harder, and it's not the protein fiber amount that's making it harder.
Calcium. Yeah.
That's it. That's what separates your bone from cartilage. It's that minerals that are in there.
Right.
Those minerals, right?
Yeah.
But see, there's a difference between an osteoid, which is just the what? That's the regular ECM you've been dealing with.
Yeah.
Whether it be cartilage or it would be. In fact, if you remove calcium and these minerals from bone, it will be cartilage. See, in chapter 6, it's pointing out the similarities between cartilage and bone, because some types of bone, long bone, it comes from cartilage.
Right.
See, it was cartilage first, but then once calcium was added to this mixture, then you have bone. You see, that's the only difference. You understand? But that's osteoid definitely has what we are familiar with already. Right? Osteoid has your actual collagen. And if it does have that, that means it gives you properties, right? So what's the properties of collagen again? Extensibility, which means that it's hard to what? Tear that material.
Right.
Collagen, if it's anywhere, it's going to be hard to tear. right? That's extensibility. Some elastic fiber in there, so it also adds what property? Elasticity, right? So that recoil feature, mostly the extensibility though, right? So it's hard to what? Tear. It's hard to tear. Mostly the extensibility property is what's going on with, but makes sense, right? Is bone easy to tear or break?
No.
Okay. And what makes it even more rigid, right, is your what?
Calcium.
Makes it rigid, right?
Right.
Right? Your protein fibers are catering to the what property? Extensibility. Okay? But now we can add another type of property because of this what? Calcium. Much what? Much very, very what?
Rigid.
Two different properties. But two different things that gave it those two different properties, right?
Right.
Your bone is rigid because of who?
Calcium.
But you have this feature of it not being easy to tear because of who? Collagen.
Maybe not
You
easy
see
to
it?
break, you mean?
Yeah, not easy to tear.
You can't tear a bone.
Yeah, exactly. And that's why.
I see why.
And that's why.
Right.
And that's
Okay,
why.
I got you.
So that feature, and that tearing was something we introduced in chapter 4 related to the connective tissue.
Right.
Just in general, whether it be loose connective tissue, which is jelly-like, or that dense connective tissue that's like rubber, hard to tear. Can't tear it because who's that? Collagen. Right? So bone's going to have that feature, but also rigid now, right?
Gotcha.
Yeah. But this is when we look at the histology of bone. And that's the difference between when we say the mineral deposit of bone versus the what? Oxy. You see two different things, okay?
Right.
Two different things. But they are all together in bone. Yes. All together in bone.
So I mean, how would I explain osteoid? I would just say it's different